But for some reason, no one ever come talk to me afterwards about it. You know, I can tell you all this stuff right here, but knowing it and being able to put it into action is two different things, right? Yeah. Derivatives of exponential and logarithmic functions. All right, so what happens now is we're moving into a new class of functions. So far, you know how to take the derivative of this. You know that the derivative of this right here is 30x to the 9 by use of the power rule, right? And we went through several examples of what to do. For example, if you have to FOIL it out first, or if you have a radical, or if you have a fraction. We went through all the rules that you need to do to get enable you to get to the answer for your derivative. Today, we're moving on to the new rules, and that is when we have exponential or logarithmic functions. Let's start as exponential functions. You all right out there? I said hello. I
Yeah.
see everybody because a few people came in late. So let me go ahead and do that. Good afternoon.
Hello.
Afternoon.
Is that to the power of 10?
Say again?
Is 3x to the power of 10?
What do you think?
No, I'm asking like.
I know I'm asking, but I'm telling you, you can figure it out. So I'm asking what you think.
Oh, yeah. Yeah, I think so.
Look at this right here. What number is this right here?
All right. That's A. No, that's a 9.
Exactly.
Oh, all right. I got you. My bad. I ain't know because it looked like a T.
I know it does look like a TO. I agree with you, but I'm just saying we can figure it out. It's supposed to be a 10. All right. So let's roll. We'll of course do this by example like I normally do. If I have the function f of x is equal to e to the x, notice that the power is the variable. The x is up here, not down here. All right. Now remember we discussed e last time a little bit, the natural number right here. Well, the number e is actually an engineered number. It was engineered for one basic purpose, and the basic purpose that it was engineered for was this. The derivative of e to the x is e to the x. E was generated so that the derivative will be a self-derivative, i.e. there is no change in the derivative. It's often called the self-derivative. It's often called the self-derivative. And hopefully that should make sense to you. But it just turns out that that number E is vital to the construction of our universe. It is the fastest rate that you put money in the bank that money can grow. It's the fastest rate. If you have a population of animals, it's the fastest rate that the population of animals will grow. If you have the leaves on the tree, the number of leaves on the tree, how those leaves grow is based upon this number E. Anybody ever did statistics yet?
Yes.
In statistics, there's the normal distribution, right? The formula for the normal distribution involves the number E. That's how. And so I don't know why, but when this world, I guess, was constructed, this was one of the base values that was used to set everything up in motion. And the key thing to it right here is this: the derivative of e to the x is e to the x. It is the simplest derivative because you have to do nothing. If I have f of x equals negative 7 e to the x, then the derivative is negative 7 e to the x. If I have another example, f of x, write properly, please. People already complaining. You know you can do better. Do better. F of x is equals to 100 e to the x, then the derivative is 100 e to the x. That is it. And that's the power of E, and that's what makes E so special. Unfortunately, this simplification of the derivative only holds for the number E. If I have a different base, then the rules change slightly other than the number E. If I have a base that's different from the number E, well, I have to introduce a rule. If I have a function f of x and then the base is not E, then the derivative will be b to the x. See how it starts out the same, just like e to the x? See how it starts out the same, just like e to the x? B of x right here. But then I have to multiply by the natural logarithm of the base. Okay, so it starts out e to the x, so it's the same thing. But then I have to multiply by what we call a correcting factor. So for example, if I have f of x is equal to 7 to the x, no longer is it e to the x. It's now a number to the x power. Then the derivative starts out the same, f flat. But then I have to multiply by a correcting factor. And that will be my final derivative. Questions there?
Where you get 1 from?
That's a 7.
That's a, oh, okay. And what that LN, what does that just mean, multiplication?
No, ln is, oh, it was in the other page. Hold on, let me go back 1 second. Stop. ln is the opposite or the inverse function of e to the x.
Okay.
Okay, it is a function. It does the opposite of e to the x. So if I say e to the x and the answer is 10, then ln will reverse that. Okay, it's the opposite function to e to the x.
Okay.
By the way, this is not in. Sometimes people, when they're trying to type it in on the internet machine, they put it's not in, it's ln, lowercase l, lowercase letter n. It stands for the natural logs. Another example. If I have a number in front of it, so f of x is equals to 4 times 8 to the x power, and I'm trying to take the derivative, well then f prime of x is going, again, starts out exactly the same. So I want you to think about, starts out exactly the same, but is this the final answer? It cannot be, because only e to the x returns the same derivative, correct? And so, which number is the base? Is the 4 the base or is the 8 the base? Which number is the base?
The 4.
Oh, the base is what's being raised to the power. So the base is?
8.
8.
We go ln 8. The way you see this in your textbook will be if I have f of x is equals to a times b to the x power, then the derivative is a times b to the x ln b. Questions there? All right, try these 3 for me and send me a message in the private. 1, y is equals to 3 to the x power. 2, f of x is equals to 5 e to the x power. And 3, y is equals to 2 times 9 to the x power. That is 3 derivatives. Send me all 3. All right, so the derivative. So number 1, y prime is equal to, it starts out exactly the same, 3 to the x. But then you go ln 3, i.e. ln of the base. So number 2 starts out the same, f of x is equal to 5 e to the x. But because it's e to the x, that's it. Nothing else. No need for ln e. By the way, ln e equals 1. That's why it's not there. And then number 3, y is equals to 2, 9 to the x power ln 9. And that is the answer for the last one. Any question there in any of these answers? All right, so let's switch gears then. Let's look at derivatives of logs. So if I have a function f of x is equals to ln of x, let's make it 3 times ln of x, like so, then the derivative f prime of x is a fraction. The derivative is 3 over x. That's the derivative of your function right here, your ln of x function. Now, normally I can explain this a little bit better in class. It's kind of hard to do right here. But what I tell my students is if you look at the expression 3 ln of x, right? This 3 right here is kind of the numerator, and this is kind of the fraction symbol, and then that's the x in the denominator. So I tell my students is that if you think about simply rotating this, if you take this right here, and the x will come to the denominator, and the 3 will come to the numerator, you'll end up with 3 over x. You just got to throw out the n. So it's kind of, when I throw out the n, it's kind of 3 over x already. And so when you have taken the derivative of an ln of x, that's all you do to get your answer. So number 2, the f of x is negative 5 ln of x. Then the derivative is simply going to be negative 5 over x. So your rule is to have a function f of x is equal to a ln, not look like a ln of x, and the derivative is what? Is a over x. One that can sometimes trip up students is if I just have ln of x like so. Well, of course, there's a hidden 1 in front of the ln of x, and so the derivative is 1 over x. Questions there? Are we paying attention?
Yes, sir.
Yes. Yes.
Yes, sir.
That's a trick.
Yes.
Only had half of your answer.
Yeah.
Mhm. When the base is not e. All right, so again, that's his note, doesn't it? I didn't put a little thing around here. It's not e. So if I have a function when the base is not e, so let's say I have f of x is equal to 10 times log base 7 of x. ln is the base e. You use log when the base is anything else other than e. It turns out that the rule that you follow is almost exactly the same. So I have a log base b of x. The derivative is going to be a over x. So again, the a will rotate to the top and the x will rotate to the denominator. But see the b right here? See that little b right there? It forms part of the denominator, L and b. You have to divide by the natural logarithm of the base. When we're doing an exponential function, you multiply by ln of the base. When you're doing a log, you divide by ln of the base. So translating that over into our example, f prime will be 10 divided by x, L, and 7. Questions there?
Can you explain the rule over, please?
So the rule is the number in front will rotate to the top. So you see how 10 right here, it ends up in the numerator. while the x ends up in the denominator. So I have x down here. Okay? But then, because the base is not e, I can't just leave it that way. I have to then divide by the natural logarithm of the base. The base is 7. So I end up dividing by ln 7. Let's do another example. F of x is negative 15 log base 8 of x. Then the derivative would be negative 15 over x, l, and 8. What's this? All right, so let me get you to try 3 of them. You found it, baby? Okay, cool, y'all. So again, 3 questions, 3 answers. Y is equals to negative 200 ln x. Number 2, f of x is equals to 7 log base 4 of x. And number 3, y is equals to 22 log of x. Send me a message, please. Come on. Let's see answer. Number 1, y prime is negative 200 over x. That is it for number 1. Number 2, f of x is equals to 7 divided by x. Kind of like over here. But because the base is not e, I have to then go ln 4. Number 3 is a trick question in that you're supposed to know that if I have a log and I don't write the base down, that means the base is 10. This is called the common log. If you have a base, if you have a log and there is no base, the base is 10. If you have ln, then the base is e. And so therefore this is going to be y prime is 22 over x ln 10. And there you go. And that's your answer right there. Questions there? Come on. Questions?
Yeah, I got a question. Why the X in front of the XLN10 and then XLN4?
That's the rule. So you see right here, looking at this rule right here, the X always is in front. Okay? Anybody else? All right. Try this one for me. Number 4. Y is equals to 3e to the x. One of the things that we like to do is kind of mix and jumble stuff up. To kind of check your, your knowledge. So, okay, any questions on this before I let you go? I'll give you 2 minutes, guys. Any questions right here? Y is equals to 3e to the x minus 6 ln of x right here. Plus, I'm going to write this as x to the negative 1 because it's in the denominator. Yes or no, or maybe so. I didn't write the 4 down. And then I have to distribute negative x to the negative 1 times this is x squared. X times this is plus 5x to the negative 1. 2 times x is minus 2x cubed. 2 times 5 is negative 10 plus 4 ln 10. Now I am ready to take the derivative. as they say in the business, a derivative. Ba, 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 ba. A derivative. So y prime, the derivative of 3e to the x is the same. The derivative of 6 ln of x is 6 over x. The derivative of x squared is 2x. The derivative of 5x to the negative 1 is negative 5x to the negative 2. The derivative of negative 2x cubed is minus 6x squared. The derivative of negative 10 is 0 because it is a constant. The derivative of 4 ln 10 is. Can anybody tell me what the derivative of 4 ln 10 is? Anybody happen to know? The derivative of 4 ln 10 is actually 0. Anybody tell me why the derivative is 0? I was going to say because
Is it because there's no X on it?
it is because there is no x. Because there is no x on it, it is a constant. And the derivative of a constant is 0. Okay? So of course, my final answer is going to be y prime is equal to 3e to the x minus 6 over x, the piece most people got, 2x minus 5 over x squared minus 6x squared. And that's the derivative of my fancy project. Questions there? I'm listening.
What happened to the negative 10?
The derivative of a constant is 0.
Okay.
Zeroed out. I think I broke it.
And where'd you get the 6x squared from?
Where am I? Can you see the mouse? See the negative 2 times the x cubed is negative 2x cubed. And then 3 times negative 2 is negative 6.
Yeah, I got you.
Anybody else?
Why did you put the X squared under the negative 5?
Because the power is negative 2. When you have a negative power, it goes.
Oh, okay.
Anybody else? Right. That takes us to properties of logarithms. Now, it turns out that these derivatives are pretty straightforward, right? You just got to remember to put in a fraction and then add in the ln7 for this example right here to get to the derivative. But it turns out that for a lot of log functions, we actually have to do some work. We have to simplify the logs first before we can go ahead and take that derivative. And so let's remind you of how we simplify logarithms. The first property of logarithms was called the sum property of logs. The sum property said that if I have a logarithm, say log base 7 of 10 multiplied by x right here, then this can be simplified. F of x is equal to log base 7 of 10, and the multiplication that you have right here between these two terms, that multiplication becomes addition, and that's going to be log base 7 of x. Another way to think about it, although it's technically not mathematically correct, is that if I'm distributing the log 7, see the log 7 right here, it give me the first term, and then the log 7 right here gives me the second term. But you just got to remember that the multiplication symbol will become an addition symbol. Questions there? The opposites of multiplication is division. And so that takes us to the second property, the difference property. If I have, let's say f of x is equal to, say, 15. I didn't write that log. F of x is equal to log base 17 of 15 divided by x right here. And I wanted to expand this logarithm. Now, in the previous example, I had multiplication. Now I have division. It ends up being the opposite. Again, expanding the log, so that's log base 17 of 5 minus, and then down here, right here is log base 17 of x. And so what happens is division becomes subtraction when you're simplifying that logarithm. And then I can take the derivative of each of these pieces very simply after I have simplified the log. Questions there? The third property of logarithms is the power property. Remember Thundercats? Thundercats are on the loose. Thundercats are loose. Thunder, thunder. No? F of x equals, oh, somebody remembered. Yay. X to the third power right here. Well, the power property says that this can be simplified. I take this right here and I move it to the front. And so it becomes 2 multiplied by 3 L, not Ln, log base 7 of x. That simplifies to 6 log base 7 of x. And now, let's say I can take the derivative. That's going to be 6 over x ln 7. And so the rule right here is that the power of x multiplies by the coefficient. Up front. Questions there on the 3 properties of logarithms. Your summation property, your difference property, and your power property. Okay, the point of all of these properties is to take a log that has lots of stuff in there and to simplify if a log that only has 1 term in there. And then once we have that, we can go ahead and apply the rules that we've learned. Okay. The basic rule right here is we simplify the complex log before we take the derivative. Everyone finished writing? Let's look at some examples. Example number 1. Let's say I have f of x is equals to log base 5 of 12x, and I want to take the derivative. I will first apply the sum property. And so f of x will therefore equal to log base 5 of 12 plus log base 5 of x. And now I can take the derivative. So f prime. Anybody knows what the derivative of log base 5 of 12 is? Anybody tell me what the derivative is? Anybody? Don't you all answer at once? Okay, fine. This has no x in it, and because it has no x in it, the derivative is 0. What's the derivative of log base 5 of x?
Is it 1 over x ln 5?
1 over x ln 5 is correct. Please remember, when you have a log and there is no x in there, it's a constant. The derivative of a constant is 0. Example number 2. If I have f of x is equals to 5 log of 3 over x squared. Well, I can use the difference property. And so f of x is equals to going to be 5 log of 3, and then minus, and then the denominator is going to be 5 log of x squared. So far, so good?
Yes.
Then I can apply the power property to the second term. And so f of x is equals to leave the first term alone. But 2 times 5 is 10 log of x. And now I can take the derivative. What's the derivative of 5 log base 3 of x? That's 5 log base 3.
0.
And what's the derivative of negative 10 log of x?
Negative 10 over ln x.
What
It would be, wouldn't it be negative 10 over XL in 10?
Mm-hmm. Remember, the base is hidden. Remember, the base is hidden. The base is 10. And so my final answer is negative 10 over XL in 10. Questions there? Don't forget. Don't. There is no base, then the base is 10. All right, last example for today. Y is equals to 3 ln of 5x to the 4th squared. This problem is slightly different in that the entire term is being squared, and so you actually have to start by doing the power property first to get rid of that square. So y is going to be 6 ln of 5x to the 4th power. Then I can use the sum property to split it in 2. That's 6 ln x to the 4th power. Then I have to use the power property again because I have x to the 4th power. And so that's going to be y is equals to 6 ln 5 plus 24 ln x. And now for your derivative. Now I use my derivative rules to get to the answer. Somebody, what is the derivative of 6 ln 5?
0.
0. And then what is the derivative of 24 ln x? What's the derivative of 24 ln x?
24 over x.
24. And so that would be your answer.